Here we have x as a random variable, and it has the normal density function of 1 over the square root of 2 pi times sigma times e to the negative 1/2 x minus mu over sigma squared. This is called the normal density function. In an earlier video, we have shown that the integral from negative infinity to positive infinity, where the integrand is the normal density function, we have shown that this is equal to 1. And again, mu is just a real number. Sigma is just a positive real number. And here we want to show that the expected value of the random variable x, or the mean of x, which is defined as the integral from negative infinity to positive infinity with the integrand of x times f of x. In this case, the f of x will be the normal density function. And we want to show that the expected value is equal to mu, is equal to this mu right here. So that's what we want to show in this video. So one more time, expected value of x is the integral from negative infinity to positive infinity with the integrand x times f of x. And so here, let z be x minus mu over sigma, which is 1 over sigma times x minus mu over sigma. From here, solve for x, we get x to be sigma times z plus mu. The derivative of z with respect to x will be 1 over sigma. Mu over sigma is constant, so the derivative is 0. So from here we get dz is 1 over sigma times dx. We multiply both sides by sigma, we get sigma dz is equal to dx. One over square root of 2 pi times sigma. This expression is constant, so we can move it and place it in front of the integral. X is sigma times z plus mu. X minus mu over sigma is z. So we get negative 1/2 z squared. Dx is sigma times dz. Sigma dividing by sigma is 1. And now we'll expand this integral. This will be the integral from negative infinity to positive infinity, sigma z times e to the negative 1/2 z squared plus the integral of mu times e to the negative 1/2 z squared. So this is the integral, the sum, and we just write it as sum of two integrals. Sigma again is constant, so we can write this as sigma over the square root of 2 pi. And then what's left is z times z to the negative 1/2 z squared. In an earlier video, we have shown that the integral from negative infinity to positive infinity with the integrand z times z to the minus 1/2 z squared, we have shown that this is equal to 0. see the description section for this video link. So this integral right here, z times z to the negative 1/2 z squared is equal to 0. And so sigma over the square root of 2 pi times 0 is just 0. And now let's look at this integral right here. This is equal to 1. In an earlier video, we have shown that the integral negative infinity from negative infinity to positive infinity with the integrand of 1 over the square root of 2 pi times sigma times e to the negative 1/2 x minus mu over sigma squared. We have shown that this is equal to 1. For the special case where mu is 0, sigma is 1, so in the place of sigma we have 1, 1, and in the place of mu we have 0. Remember that mu is just any real number between negative infinity and positive infinity. Sigma is just any positive real number. So as long as mu is a real number, any real number, positive or negative, and sigma is a positive real number, then this integral is equal to 1. For the special case where mu is 0, sigma is 1, then in the place of mu we have 0, in the place of sigma we have 1 and 1. So we end up with 1 over the square root of 2 pi. X minus 0 over 1 would just be x squared. And this is also equal to 1. So this is also equal to 1. And so instead of here the integral is in terms of x. Here this integral is in terms of z. So the integral from negative infinity to positive infinity, e to the negative 1/2 z squared dz, and then times 1 over the square root of 2 pi. This integral is 1. And so that's how we end up with 1 here. And so mu times 1 is just mu. And therefore we have just shown that the expected value of the random variable x is equal to mu.